This looks like a lot of text, but it's okay, it's easy. So we have another scientist's face. In this case, this is Rutherford. And this is 1909. And basically, he did a very famous experiment. This is gold, okay? So a very thin piece, like a paper of gold, very thin. And when you have a very thin piece of gold that looks like paper, we call it foil. That's what this word means. So gold foil experiment. So we had this gold foil, and what they basically did, they shot. So what you see here, they shoot from this point, they shoot positive particles here. So positive charge is being thrown at this gold foil. Now, gold is an element. Gold is made of atoms as well. So they were basically trying to find out what happens if I shoot positive particles at a lot of atoms. And what happened was really interesting. So when these positive particles were basically meeting the foil, the gold, they were going into all kinds of directions, which is interesting. Because if you think about it, if the model looked like this, then they all should kind of just go through the gold foil. It's all evenly spread out. There's no big difference. But if it goes into all angles, one goes more left, one right, one straight, then or even some would go completely back. So completely back all the way, reflected. Then it's not just spread out. That means that the mass of an atom is concentrated. And you remember the word nucleus. So it means it's in the middle. Something is there. A positive charge is focused somewhere in a center, like concentrated. And when it meets it straight on, positive, positive, it will deflect, right? It will go back. As you said, it pushes it back. So if this is positive, the nucleus, if this meets the nucleus where we have positive and neutral, and all the positives are here, let's just say this for now. And let's say it meets this. And as you said, positive, positive, the same as negative, negative, they don't attract, they actually push away each other. So these would just go straight back, okay, the positive particles. So because of that, they found out that there has to be a center. It can't just be spread out like the plum pudding model. It has to be with a center. So in this case, we have this model, which we saw in our timeline. So now we thought there's a nucleus with a positive charge. We know now more, but for that point of time, they thought now it's positive center, nucleus, and there's some empty space, and then there's the electrons around it. So this is a point, the difference would be before we thought it's spread out. Now it's basically circling around it, the electrons, and we have a center. Okay,